Now we're going to go to the part of the shop where we do our steel stamping. As you can see on our dice project, we got all of our dots in there. We're ready to do the stamping. We have the students stamping the number 1 side, which I'll come to later on as to why we do that. But we have all the students identify it all on the number 1 side. On this particular plate here, this is just an old cast iron surface plate that we've converted over just as a base so we can stamp with. We have a piece of aluminum already here that the students can practice their stamping on first before they actually do the stamping. 1 aluminum, 1 steel. Took the liberty to make a fresh one so that when we do stamp it here, I can show you what it's supposed to look like. We also keep some paper underneath here for the students to set their dice on, because sometimes this gets dirt, or you can see there's some imperfections here and there, and we don't want them to transfer it to the dice itself, so we put a little piece of paper on there to help prevent that. Also, we bring out our tackle box, which is our stamping kit, which has got all the steel stamps we have for our shop for the students. It has numbers as well as letters, and we keep a little hammer in here as well. Okay, so what we're going to do is we're going to pick out the appropriate numbers or the letters for what we're going to do. We ask them to put their initials in. Mine is RS, so I'm going to go ahead and do that. As you can see, there's a little groove on the initials right there. That's pretty much uniform in all stamps. They have some sort of identification mark which indicates which side you hold your thumb against. That sets the letter up so when you stamp it, that it is right side up. You know, like on the R here, if you were to find that, you'll see that the bottom of the R is there for when you stamp. Now I'm going to go ahead and do a practice stamp over here on the piece of aluminum. So you hold your stamp dustly. I like to grab it right down at the bottom. That gives me a little more control over it and helps to keep it from bouncing. We give it a tap, and then we go ahead and take a look at it to see how it does. So as I zoom in on the R, you can see that the R looks pretty good. I'm going to go ahead and put an S in it right next to it. So we take our stamp, we hold it correctly. I hold it right down on the bottom. Push my hand where I'm resting it on the surface itself. Give it a wrap, and you can see that the S came out just as well. Now, as we go over to our block that we have going on, I'm going to go ahead and stamp the R and the S in. I'm going to just, there's no really rhyme or reason. It's wherever the student wishes it to be. I hold it right down on the edge. I give it a wrap. As you can see, I put my R in. Then I'm going to go ahead and put my S in all together with it. So I'm just going to offset it just a little. I think it gives it a little better look. And there we have the R and the S stamped in the number 1 side of the dot. Now we're off to polishing. And this part of the shop is our polishing area, or what we have is our lapping only, okay? This is just nothing more than a similar plate to what was over there, only we went down the street to the technical college down the street because they have a bigger machine than what we have, and we went ahead and ground in the plate to make it nice and smooth across the top, okay? And we're going to go ahead and do our polishing on that. What we have is we have two different, each student gets a strip each of this particular emery cloth, one being at 600 grit, one being at 1000 grit. We wrote it on the back for them to know what they're doing. And I'm going to show you in just a second how we go about polishing this. Now what I've done is I went ahead and wrote 600 and 1000 on the paper itself. Okay? This particular system, when we do our stamping, it kind of raises up on the initials here, so we want to always stamp first before we polish, or at least if we stamp after, come over and back and polish it again, because it makes a difference when we go to inspect it. What we ask the students to do is to go ahead and, everybody's got their own method, but I usually turn the block like this as I'm polishing. We ask the students to polish first on the number 600 and then go to the number 1000. Now depending on how much time they took on their finished cuts, what we're trying to polish out is the cutter scars, or their circular cuts in there. I don't know if you can see that, but there are like significant little surface lines which are the actual cutter marks as they came across. So the slower I went, the less there'll be of them. So if we take and tell the students, they can sit there and go like this, they can go like that, and then turn it and go like that, whichever they prefer. But I usually turn it as I'm going back and forth to get the best surface possible. And after they do it on that one, then they can come over here to the 1000 one, and give a finished look to it. Okay? And we're trying to get the nicest finish possible without getting carried away. I'm going to go ahead and continue to do this on each particular one. I like to start out with the number 1 and give polishing on it. Then do a little finish work on it. Okay? I think the number 1 looks good. I'm going to go to the number 2 next. Okay, you can flick the paper, clean it out. Okay, I'm going to go to the number 3. Okay.
And what you may ask is why we do this to polish it. We want to give the students some experience with emery cloth. This is not sandpaper. It is called emery cloth. People in wood shop use sandpaper. People in metal shop use emery cloth. Okay? They also have finer stuff which they refer to as crocus cloth, which is just super fine emery cloth. That's the number 3. We're going to go on to the number 4. Okay, number 5. And a number 6. Okay, it looks like we got all of our sides. I'm going to redo on the number 2 a little. Okay, looks good.
We're going to concentrate our efforts over on this granite surface plate. We have a station for 2 people to work at the same time, but we're going to concentrate on this one right here. Okay? Like I was saying earlier, some of our tools are in pre-marked containers so that we can take and bring them out as we need them, and the students know exactly what they have and what they're working on. Right? The students are making their projects with digital calibers, but what we do when we get them over here, we want them to have experience with dial calibers as well. I'll go into how to use them in just a moment. But our colored ones are a little different than our ones with the white faces in reference to how they are on the end of it. We modified a couple of them to do a specific task, especially on the dice project. Okay? But this is where we're working at, and this is what we're going to do. These are our dial calibers. These are our holding devices and inspection bolts and nuts for the different parts of the job. As we begin our inspection on our dice project, I'm going to go over a little bit of items on the blueprint itself so that we can understand just how we're going to write down our dimensions. In your original paperwork that was passed out the day of orientation, I had you fill out your name on this particular sheet of paper. This is the inspection page, which is actually the back side of your dice project. Okay? So, on this side, you've already wrote in the information concerning the class, your time and day that you have the class, etc. Now, over here, everything is color-coded as far as which dimension goes in which spot. This is hanging up in our inspection area generally, and then what you would do is you'd be able to see when you come over to do your inspection in our inspection area which dimensions go in which boxes. Now this 1, 3, and 5, that pertains to your dice project in reference to the 1 side, then it would be the 3 side, and then it would be the 5 side, as far as checking the overall distances that we have here as far as the 1, 3, 5. That said, what you would do is when you inspect your part, you would write your finish dimension here, here, and here for the 1, 3, and 5, as to what these dimensions actually are. Now, everywhere there's an abbreviation on our sheet where it says PL, which means places, how many places there are. Anytime there's abbreviation, we refer to what the abbreviations are right up in this area here, if you get confused. Okay? As we go down the line, we're going to check the 1, 3, 5 on the overall dimension, here, here, and here. Then as we go down, then we're going to check the 12 places for the 80,000 chamfer, which would be up here in the turquoise, and that would go here. Okay? Then as we continue down, we have dot location, which is a pink sort of color, and that would be indicated by here, and that would be the calculated amount from the edge to the edge of the hole, as far as how far it should be from the edge to the edge of the hole, so we can check our location on all of our corner dots, and also on our number 6 dot from there to there, and from there to there. Then what we have is we also have on here a dimension between on the 6 dot from there to there, and from there to there, which would be 1.125 or 125 thousandths, okay, in order to catch location. Okay, that would take care of location, and we have 42 places. If you count up all the dimensions there are, it comes up to be 42 times. Each dot has 2 dimensions from one direction and from the other direction, whether it is in where it's supposed to be. Our center dot is just within 10 thousandths of being one center, is for the location of all of our center dots, okay, to add up to 42 dots total. The 3/16 diameter, we have 21 dots, there's 21 places, and the diameter is determined by the diameter of the cutter. If we use the appropriate 3/16 diameter cutter, okay, they should all come out correctly. The only time they don't is when somebody gets in a hurry and they slam their cutter into their project when they go to begin to machine this hole, and a chunk of the aluminum gets stuck on the end of the cutter generally, and then they waller this hole out just as big as what the cutter will allow it to waller out. And it's obvious when you look at it, you'll see nice uniform dots, then all of a sudden you'll see one that's all wallered out and really too big, and that one they don't get credit for. Okay, the depth. The next one down is the depth, which is here. The depth is 50 thousandths deep, 21 dots, 21 places, and what we'll do is we'll determine the depth via the inspection equipment that we have, and we'll write down how many are correct. The initials in the dot, if we stamped our initials in where it's supposed to be, will give us a yes or a no, or Y or yes in that location. Perpendicularity, we will get to that in a moment. Parallelism, 1, 3, and 5. We will circle each one that we have correct within 10 thousandths, okay? And as we're checking this 1, 3, and 5, we'll go ahead and check our parallelism on 1, 3, and 5 and circle that at the same time we're doing that dimension. The last thing we'll be checking generally is the perpendicularity, which I'll go into it as to how we go about that. And again, we'll check it on 1, 3, and 5 and circle how many we have correct. Our tolerances are below in our tolerance box. Our perpendicularity call out is here under a special note. And what we'll do is we'll go ahead now and get started. I want to go ahead and introduce you to some of the inspection equipment that we're going to use here right now in inspecting the dice at this particular point in time. What I have is I have a 1-inch standard right here. It's actually what they call a 1-2-3 block. This is my own personal 1-2-3 block, and I know it's exactly 1 inch from there to there. Okay? Now, we have up here, this is referred to as a 1-inch travel dial indicator. Each one of these marks as we go around the clock dial here is represented by 1/1000th of an inch. And every time this dial makes a full revolution on this clock dial here, this little clock indicates how many revolutions we've done. 1, 2, 3, and 4. Now each revolution on this is 100,000ths of an inch. Each mark is 1/1000th of an inch. And every time we make a revolution around there, each one of these numbers represents 100,000ths of an inch. If we go to the 1 and at 0, it's 100,000ths. If we go to the 2 and it goes up to center, it's 200,000ths, and so forth. So every time this comes up and you watch it make a full revolution, we'll zoom in a little on that. Every time this comes up and we make a full revolution on the dial, you'll see that the little needle goes to the number 1, and then as we come around to the number 2, like right there, that would be 200 thousandths from the bottom of the pointer to the top surface of what we've just left, and that would be a ½ inch above right there, right about there, and that would be a ½ inch above what we've just come off of. Now we're going to go ahead and begin checking our dimensions on our 1, 3, and 5 on the overall thickness of the block and the three sides that we're going to check. Naturally, we're going to start out with the number 1 side. I'm going to go ahead and raise this up and slide this underneath. We started out 0 on the 1-inch standard. Okay, so now our block, when it's at the 0 setting, which is here, is at 1 inch. Now we're going to go ahead and raise it up. 1 full turn, 2 full turns, and then not quite 2 full turns. It'll stop here at this dimension right there. Okay, now I'm going to go ahead and zoom in so you can see what's going on the clock dial itself. Okay, now again, I'm going to start over. Again, this is at 0, and then we're going to go turn, turn, and then we're going to come up, and that's what our dimension is. I'm not going to tell you the dimension because I expect you to write it down on your paper. Okay, we're checking 2 things here. We're checking parallelness within 10,000ths of an inch, okay, and we're checking the dimension. So right now on your paper, I want you to write down what dimension you read on that particular dial indicator on the number 1 side in the box provided. Now, from there, we're going to go ahead and zoom out a little bit. I'm going to show you that I'm going to flip the block over to the number 3 side. We're going to raise up the dial indicator and put the needle on top. Here again, I'm going to zoom in so you can see just what's going on with the dial itself in reference to the dimension. Okay, now we're going to check parallelness to see if it's within 10,000ths of an inch of being parallel. And I'm going to let you write down whatever dimension you see there in reference to taking into account that we started with 0, how many which would be automatically 1 inch, plus how many thousandths of an inch above 1 inch we are. Okay, I'm going to zoom back out. I'm going to drop the needle down. Now we're going to go to the number 5 side of the dice. We're going to put that facing up. You slide it around, make sure it's nice and flat. We're going to go ahead and lift that up and set that on the number 5 side. I'm going to go ahead and zoom. We're going to go ahead and check it for parallelness to see how parallel it is. Whoops, slipped off into a hole. See how parallel it is? It's parallel within 10,000ths. And now we're going to go ahead and set it in 1 spot. And I'm going to zoom in so you can read what it says on the indicator. Okay, now we've got that part of it done. So now what you've done is you've indicated in these boxes 1, 3, and 5 what dimensions they were based on these dimensions here, which would be this dimension, that dimension, and this dimension. Since we already have a setup, we're going to go ahead and check the depth of these little counter bores that are here, are the dice dots. We'll refer to them from this point forward as the dots. We're going to check the depth of the dots on the dice to see if they're 50 thousandths deep. And here again, it is a 3-place decimal. So if we look down here, we'll see how much tolerance we have in reference to the tolerance block on a 3-place decimal versus a 3-place decimal. And then we're going to go ahead and drop in. And what it's asking for you over here on the depth of the dot is they're asking you for how many places is correct. Okay? So based on how many places is correct, we're going to go over here. I'll zoom in on that so you can see, make sure that you understand. It's asking for how many places is correct. We'll go back around here to our indicator. We're going to start out and do this in sequence, so you better get a pencil and paper and follow along on how many is correct on the depth according to the blueprint. We're going to go up here, and to simplify things, we're going to zero this out. We're going to zero this out to 0 at the top. I'm going to zoom in now. We're going to take and zero our indicator on the top of our dice And then what we're going to do is we're going to go ahead one at a time, and we're going to drop it down into the hole. And you're going to write down from there how deep it goes, and you're going to write down what dimension you see. Going to the number 2 side now, we're going to go up, and you can see our indicator is 0 at the top. Okay? We also can adjust it on here. We're going to drop it down into the number, one of the dots on the number 2 side. See what dimension you get. We're going to bring it up and bring it over and drop it down on the other side. See what you get. Write those down. How many of you, if it's correct or incorrect. We're going to go to this side here. We're going to drop it down in number 3, based on a tolerance, whether it's correct or not. Based on a tolerance, whether it's correct or not. Based on a tolerance, whether it's correct or not. We have the number 3 done. Now we're going to be flipping it over to the number 4 dot. We're sitting up on number 4 side now. We're going to slide it over and drop it down in the first dot of the number 4. We're going to drop it in the second dot. Okay, take that dimension. We're going to drop it down into another one. And the final dot we're dropping into at this point in time. Okay, now we're going to roll the dice dot block around till we get to the number 5. We're going to check to make sure it's 0 up at the top. And then we're going to drop it down into, let's start with the center dot. Then we're going to go to the first corner. Write down whether it's correct or not. This one, whether it's correct or not. This one, whether it's correct or not. And this one here, whether it's correct or not. Now we're going to go to the number 6. We flip the block over to the number 6 side. And we're going to start dropping the dots down into there. We're going to drop it down in the first one, whether it's correct or not. Into the second one, whether it's correct or not. Into the third one, whether it's correct or not. Into the fourth one, whether it's correct or not, based on, come there, drop down, bring it up out of the hole, into the 5th one, whether it's correct or not, and finally the number 6th one of the 6 dots, whether it's correct or not. Now, what we've checked is we've checked all the depth on all the dots as we went along. You're supposed to keep track of how many were correct and how many weren't, and wrote that down on your paper as to how many were correct in that spot. So, what it's asking for over here in the dots, as far as the depth goes, it's asking you how many were correct as far as the depth of the dots. 21 possible. How many did we get correct? What we're going to go to right now is we're going to go to the dot diameter. How many is correct? So what we have here is the 3/16 diameter. Write down how many is correct on the diameter, or possibility of 21 places, and how many we have correct. As we go over here, we can see that the dot diameter is 3/16 of an inch. That's governed by the cutter itself. We don't have a lot of control over that, except for if we get in a hurry and slam our cutter into our project when we start to machine that hole, then a piece of the material gets stuck on the end of the cutter and make the cutter wallow around and make the hole look incorrect. So what I'm going to do is I'm going to show the dice to you, and I'm going to turn it from side to side, and you look at the holes, and you sit there and see whether it looks good to you in reference to the trueness of the hole itself. That's the 1. That's the 2. That's the 3. That's the 4. And that's the 5. Go around here till we locate the 6. There's the 6. If the diameters all look good and true to you, we'll call those all correct. And if not, how many were correct? On this, while we're over on the checking this, we're going to go ahead and check to see if we put our initials in there. It's a yes or no on the initials. On the number 1 side of the dots where we want it to be, and there's a specific reason why I want it there. I want all the students to put theirs. So let's just hold it up and see if we stamped our initials in the number 1 spot on the dice. And as you can see, whatever you see. We're going to check our chamfers now. Checking our chamfers is a little tricky, okay? Our chamfers, we have 12 places that we could possibly get correct, okay? Now, it's a 45-degree angle, so the chamfer is going to be the same direction one way as it is the other. The chamfer is 80 by 80. As we come over to our print over here and see where the chamfers are, we can see that the chamfers over here are 80 thousandths by 80 thousandths as far as that dimensions. Now, the way we check those, we ground on a pair of calipers, so that makes that an easy check with that. So I'm going to go ahead and set the calipers up and show you how that's done. And what we're looking for is how many are correct. Now, the way we're going to do that, this is a 2-place decimal. We come down to our tolerance box here and see what a 2-place decimal is as to how much we have as far as how big they could be and how small they could be. So I'm going to go ahead at liberty and set the calipers on the smallest dimension possible that they could be based on the tolerance. And then I'm going to go around to each individual chamfer one at a time, mark them as I go, and then I'm going to go around and I'm going to come down here and I'm going to set our calipers up to the largest it could be based on our tolerance. And then we'll go around the whole block and see if any of them are any bigger than the largest they could be, again, based on the tolerance given. And you write down over here in your box how many are correct. Okay, so the chamfers can be 80 thousandths of an inch by 80 thousandths of an inch. If we come down here to our tolerance block and see it's a 2-place decimal, with 2-place decimals we have plus or minus 30. So using that as an example, what we'll do is we'll run our calipers out to 80 thousandths, and then we'll count back 10, 20, 30. So 50 thousandths would be the smallest that they could be and still be correct. We'll go ahead and tighten our lock up on the bottom of our dial indicator, our calipers. And what we're going to do is we're going to start checking them. It's a little tricky finding a place where the lighting is just perfect in order to do this, but we're going to start out on our number 1 side is checking that. Now we set the calipers, as you can see, on 50 thousandths, which is how much it is from in here, from there to there, and that's the smallest they can be. With our number 1 side up, we're going to start checking them. They cannot be any smaller than that. Okay, I'm just going to go around the number 1 side and check all the ones on the number 1 side. They cannot be any smaller than that. Okay, now I'm going to flip the block all the way over and check the number 6 side. They cannot be any smaller again. Okay, now I'm going to flip it over to the number 4 side. Okay, and now I'm going to flip that over to the number 3 side. Again, we have 30 thousandths tolerance down here. We're going to go ahead and set our calipers. The dimension is 80, so we're going to go run our calipers again from where they're at up to 80, and then we're going to go 10, 20, 30 larger, okay? And then we're going to lock our calipers in place. As we did before, we're going to start to check our block with the number 1 side. Now, none of our chamfers can be bigger than this. Okay, then we're going to flip it over to the number 6 side. Again, we're going for how many are correct. I think I covered them, but I wanted to make sure. Then we're going to flip it over to the number 3 side. And then we're going to flip it around to the number 4 side. Now we're going to do our inspection on our dot location. That's a lot trickier, so just kind of bear with me as we kind of go through this. Again, we're going to use the same caliber with the ground, one of the nose ground off on it, and we're going to shoot for this 218 dimension from the edge in on all the dots, from the sides in that have location, from the sides in. Got to keep count. I think the count, let's see over here if they're all correct, dot location. We have a possibility of 42 locations, okay? What we're going to do is add up how many of these that we have correct and how many that we don't. So we're going to take the calibers, and I'm going to take and re-zero them. We're going to come around here and check to see how they're doing. We're going to start out with the number 2 dot as far as the location of the number 2 dot, as far as whether it's correct. Going to the number 3 dot. Do that again over here. Going up to the number 4 dot. There we go. I'm going to find it if I looked hard enough. Okay, I'm going to go around to the number 5 dot. Okay, going to go to the number 6 dot. Okay, now we're going to go to the number 1 dot on each one where it is a 1. So that would be, we're going to go to see if it's center within 10. Go this direction. Then we're going to go to the 3, or the center on the 3 dot. Then we're going to go to the center on the 5 dot. And then we're going to use a different pair of calibers. The last of the inspections with our calibers we're going to use to check this 125 dimension here. That's the distance between, the calculated distance between the 2 dots based from edge to edge and edge to edge. We're going to go ahead and use a different set of calibers, which we'll make sure they're cleaned out, bring them down, make sure there's 0 setting on their 0, and we're going to go in here and check that distance to make sure it's 125 thousandths within 10 thousandths of an inch. Okay. In the normal class, when you got done inspecting your project, you would bring me your DICE project together with your inspection sheet all filled out. You'd have all this filled out correctly at the top. You have an option to be keeping track of your hours across the top as you go along with your project. I would look at your project and check it out as far as the accuracy of what's down here. I could spot a bad dimension from across the street with the door closed. Okay? And once I've been satisfied that you inspected it properly and took due care and time to do that, then I'll modify the project. I would put it up here on the machine. Okay, we're back in business. Some scallywag unplugged my drill press over there. Okay, turn this on, hold this by hand, come around. Pick up our center. What I was shooting for is down in the bottom of this. I don't know if you can see it or not. Down at the bottom of this is a little bitty dot that I just put in it. Little bitty dot that I just put in it right there. That indicates that that dot has been inspected by me and returned to you to take home.